question 16 now. And here's a question where it's got some teeth in it. So we've got a, kind of literally actually, the population of mountain lions is represented by this logistic equation where t is measured in years. Now for this question, I'm going to use a calculator when there is no other choice to use a calculator. But when there is a choice, I'm going to refrain from using it so you can just see how this is solved. Obviously, things are made a lot easier if you make use of the solver on your TI-84. So getting started here, we're supposed to find K and the carrying capacity. And if I compare the differential equation that is given, dp dt equals 0.06p minus 0. And I think that's 4 zeros, 75p squared. That doesn't compare favorably with dp dt equals kp m minus p. They don't really look the same. And, my little brain tells me that I need to do some factoring here because I see that the p is factored out from here. So I'll do a little bit of factoring. I'll take the p and divide that out of each of these terms. And that gives me something that's getting close there. Okay. But now I look, and p here does not have a coefficient, and this p has a rather long coefficient here. So I'll factor out that coefficient, and which means you'll have to divide it out of the first term as well. And now things look pretty good. 0.06 divided by 0.000075, that got me 800. So now as I compare the numbers, I've got this 0.000075 in the same position as the K, and I also have 800 in the same position as M. So that's pretty good justification for me to say that K is equal to 7.5 times 10 to the negative 5, I believe. And then M is equal to the carrying capacity. And that's equal to 800. Now, I was very careful to write the word carrying capacity here because the question isn't asking what is M. The question is asking what is the carrying capacity. So at some point I better notate what the carrying capacity is. Just leaving it symbolically as M may not be good enough. So moving on to letter B, we have the initial population is 25 mountain lions. So we're supposed to find the population in terms of T. So the population equation, and you should have this memorized for logistic growth, that's equal to M over 1 plus A e to the negative m k t. Substituting what I currently have, M is 800, 1 of course, A I don't have, M times K is actually this number right here. So that's negative 0.06 times T. And what I'm missing is a value of A. Luckily, they give me the population at time equals 0. So that gives me an equation where I can solve for A. So P0 is equal to 25 mountain lions, and that's going to be equal to 800 over 1 plus A e to the negative 0.06 times 0. Well, guess what? Negative 0.06 times 0 is 0. So this is 1 plus A e to the 0 power. E to the 0 power is 1, so that's even better. 25 equals 800 over 1 plus A. Continuing to solve here, we can say that 1 plus A equals 800 on 25, which is 16. So that tells me A is going to be equal to 15. Whoops. 800 over 25 is 32, so A is 31. So to answer the question then, the population equation is going to be equal to 800, 1 plus 31, e to the negative 0.06 t. Remember that the common misconception here is A is not equal to the initial amount. At least it's not equal to the initial amount when we are looking at logistic growth. Okay, finally, how long will it take for the population to reach 4,500? Sorry, 450. It's not going to reach 4,500 because the carrying capacity is 800. All right, 450, when is that going to be equal to 800 over 1 plus 31 e to the negative 0.06 t? Well, to solve this one, we're going to have to, again, do a little bit of manipulation of the fractions, and we'll say 1 plus 31 e to the negative 0.06 t. That's going to be equal to 800 on 450. 800 on 450 is 1.7. And I'm going to keep 5 decimals here so that I don't have any, well, I try to reduce the rounding error. We're going to subtract 1 from both sides and then divide by 31. So we'll get e to the negative 0.06 t is equal to 0.77777 over 31. Using natural logs, if we got negative 0.06 t is equal to the natural log of this 777 over 31, which means t is equal to that same natural log over negative 0.06. That's 61.421. So there will be 450 mountain lions after 61.421 years. Now, I would be remiss if I didn't show you this on the calculator. So let's get to the solver. And the first thing is to write down the exponential growth equation, the general solution, into the solver. Now, if you have a TI-84 silver like mine, then you're going to have to do the left side minus the right side. Be careful with the parentheses. That is a place where people kind of mess up. So let's see, we have 1 open, 2, 3 opens, and 1, 2, 3 closed. So that looks pretty good. And we're going to scroll down. And we're going to put in values that we know. So let's pretend that we didn't know the value of A. Let's figure that out right now. If you remembered, there are 25 mountain lions when t equals 0. Our carrying capacity is 800. Our A, we're going to pretend we don't know. And our K was 0.000075. Now, there were 25 mountain lions at t equals 0. So I want to solve for 800. So I'll just go alpha, enter, and that should give me something wrong. Oh, silly me. I cursored over to the wrong place. That should be 800 there. When you're doing A, it's good to have a number to start with, and I always start with a positive number. A is almost definitely going to be positive. So let's start with 20, and we'll do alpha enter. And there we go. Our A is 31, just like we predicted. Now, to finish this problem, we wanted to know when P was 450. So we'll change our P to 450. And now the variable we want to solve for is T. It's inadvisable to start with 0. So let's start with a positive number. Let's pretend I didn't know what the answer was, and I'll put 10 there. And now we push alpha, enter. And that gives me that 61.421 again. So the solving becomes a lot easier when you have a calculator, and it becomes even easier if you know how to use your calculator really well. So that's it for us. And I will see you for the next problem.